Okay. There, I'm recording too. Okay. So let's just dive on into it. I saw that you got yours all the way done. I wasn't able to finish the Huffman. What's the? I wasn't able to finish the
Huffman tree, or
I wasn't able to finish the Huffman tree, but I got the B note tree done. It was pretty simple.
yeah, that's what I found. This one was like, it seemed it was supposed to be more complicated with the extra nodes, but it just seemed a lot easier than the other ones we've done.
Well, since we kind of since we understand like I understand how the recursive functions would make it a bit more complex, but like since it's basically adding another pointer to a linked list, and you know you know
Yeah, but I'm really glad that they put that pseudocode in for the recursive functions, because I think I would have been lost there.
yeah, that would have been pretty rough.
Those just really, those recursive functions just really mess with my head.
Yeah, no, I agree.
Mhm.
Okay, so why don't I'll walk through the binary node, and then you can show off the rest.
Okay, sure. Go ahead.
Okay, so here, this is the binary bnode.h file name, include IO stream. There's only one class and it's pretty small. It only has public data, public things. Node for left, right, and parent. And then it has, of course, the default and non-default constructors. Only difference between the two is that the non-default constructor takes a template for the data. I think I might have labeled that wrong. Hang on. There we go. That should be better, right? Yeah. So then moving on, the function has two main things: add left and add right. That would kind of work the same. So first thing you do is you allocate the pointer. If it doesn't work, you got to send the throw the error message. So there's two ways to do it. There's the one when you pass the data as a parameter, and there's one where you pass the pointer as the parameter.
Right.
So in the one where you pass the data, you make a new node with the data, and then you add, let's see here, yeah. So then you take the original node that you're doing, the parent node rather. Take the parent node, and then it'd be padd parent equals p node. So this guy right here, or yeah, or this guy right here, and then p node.p left. So you just link them together, basically, and then. Same thing for this guy. If you send a node instead of the data, except it's just cleaned up a lot. It just makes it just a lot simpler. Let's see here. Same thing. The right and the left are the exact same, so I'm just going to skip the right. Copy B tree. This is where we start to get into recursive functions. So copy. This one you need to, let's see here, delete. You need to delete that one. So you copy the new one first. Yeah. So copy B tree. It sends a pointer as a pointer to a node as a parameter. I saw in yours that you changed the name, but I kept the name the same as it had in the book, just because I didn't want to invest that much brain power in figuring that out. if the source is pointing to nothing, then you stop your recursive function. So that's our exit that's our exit condition. So let's see here. Then we allocate a new pointer to the destination. The destination equals the node of the data, and then you copy p left. Then if destination p left is null, destination p left parent equals destination. Now this didn't make a whole lot of sense to me, but I just kind of copied it, and it works. And then same thing for the right. And then you return the destination. You return the destination tree. For delete tree, it's essentially the same thing as copy, except you'll notice that we copy left and right before we delete the top one, because you obviously, if you deleted the top one first, the root first, you would break the links and you wouldn't be able to access the left and right.
Right.
And insertion operator is, it's a standard insertion operator.
Let's see. On your delete tree function, I believe that parameter need to be passed in as by reference. At least that's what the book had it as.
Where is it?
So just the and sign after that pointer.
Right here.
Before the node, after the before the node and after the pointer. So.
Right here.
Mm-hmm.
Cool.
And I believe it said that's so you can delete the actual pointer.
Right. That makes sense.
So I believe that was the run. I may be mistaken, but I believe I saw that in the book. So.
All right. Cool.
But yeah, pretty much I thought it was pretty easy this week. They gave us a lot of pseudocode, and it was pretty straightforward.
As I said, it helped that they started us. They got us pretty solid on lists and linked lists before they did this. Because it's
I just felt myself using a lot more brain power on the linked lists than on this one, huh?
That was a new concept then.
Yeah. Right. So, but yeah.
I'm going to stop sharing. You can go ahead and take over.
Okay. Let's see. I'm kind of wondering if why the video was messing up last time is because I was using PuTTY maybe, and that may have been using extra bandwidth or something.
Maybe, I don't know. We'll see. I'll shoot you an email. When I'll look at the video and then shoot you an email when we're done to see if it worked.
Okay, so I was wondering if maybe you could pull up mine on your Visual Studio. Well, actually, I don't know. Maybe it's difficult for you because you have Visual Studio. But
let's see. I don't think I can.
Okay, I have a MOBA Xterm also. Can you do you have to have that running while you're looking at the files, or do you have to?
No, kind of. The files should be saved somewhere on your computer. So if you do a search, if you do a search for MOBA Xterm, you should be able to find the files. But I haven't been able to get onto our group's account on this computer for some reason. But what was I going to say? What we should start doing is using GitHub. I can show you how to use GitHub after we're done here.
Sure. Yeah, I've never used it. I've heard people using it, and would be curious how that works. So.
Oh yeah, no, it's a great tool. Let's see here. But yeah, like it's really good for passing information back and forth.
Let me see if I can pull up one of my files on MobaX here. Let's see. I don't know. Maybe let's see. Because I feel like that's why maybe it was slowing down, because I had something running in the background.
Oh, here,
while I was
actually,
recording.
I think I can. Let's see. What files do you need? What files do you need?
I just need. Let's see. Huffman, the main one, Huffman.cpp, I believe.
Okay. Yeah, I can. Give me a couple seconds here. I can send it. I can show you how to use GitHub real quick too. Okay, so here, why don't I take the screen back? All right, so GitHub, you just go into github.com, create an account, and then hang on a second. Yeah, so github.com, create an account, and then it's a little weird just starting out, but I really recommend downloading the desktop application that they have for it. And to do that, you could just the way I did it is I just created a new repository, and then hang on a second. And then click this button right here to set up in desktop, and then they walk you through the installation process right there. But so like right now on my laptop, I'm downloading just Huffman.h or Huffman.cpp or both.
Huffman.cpp would be fine, because A.H just has the prototypes. So.
Okay. So what I'm doing on my laptop right now is I'm downloading that file onto my laptop, onto a folder that I have set up that GitHub reads directly from. Now, I'm opening GitHub on my laptop, and I'll show you guys how to do this once we get going. But the next CS class, CS 246 uses GitHub just a ton.
Yeah, I'm gonna be taking that next semester. So.
Yeah.
So.
So like, there you go. All right. Come on, faster, computer, faster, right? Okay, so really quick here. So we'll see. So CS 235 week 08. That's the file I've got right now. And now
Probably with Zoom running, it's just kind of slowing down your computer.
Yeah, I think so. All right, there it goes. All right. Just gonna refresh this a couple times. There it goes. So now there's Huffman.cpp, and so now I can open the GitHub desktop on here, and pull. Under GitHub here. That's all right. There it is. Cool. Okay.
All right.
All right. So that only took like 20 minutes. Okay. So let's see here. So we're
going to go ahead and scroll down it, and then I'll just kind of explain it as you go. So.
Yeah. So we got all the included libraries we need. There's a lot of them. All right. So.
And I created like 3 other functions to help out with each task. So I have a display function which displays the Huffman codes after it's sorted. The monster function is the combined trees one. That's the
okay.
That's where most of the work is done there. So,
right.
And that is takes a list of the starting nodes and then combines them together to create a huge tree with one node. So.
Okay. That is big function.
Yeah. And as I was working on it, I was kind of wondering if I'm doing it the hard way, but it was fun still. So
nice.
Then find smallest, it finds the 2 smallest frequencies and then returns them. Returns the iterators to them. So
okay, so
that bottom function is the where we start there. So
okay, so this is the first one. Okay.
Yeah, that's the original one.
So it takes a file name, declares a data pair, and declares a node out of it.
Right. It gets pretty complicated with that node because it's like it's a node to a pair, and that pair has 2 values in it as well. So
yeah.
And it's a pointer too. So
yeah.
Yeah. So it gets pretty complicated, but basically it's just a pointer to a pair node.
Okay. So the pair is just a data type that takes 2 different values and pairs them together.
Right. So they those data that stays together, the 2.
Right.
Because with the I don't know if you saw the Huffman files, but there's like a string name of like a letter or like a word, and then there's a frequency.
Okay.
So
it takes the name and then right. Okay, so it starts by declaring a pair, data pair, then it declares a node, and then it makes a list out of those nodes.
Right, or at least it declares the list, and then it opens the file and adds the pairs.
So we start with opening the file with the file name. And then while receiving data pairs, the binary node is made with the pair, and then it gets put onto the list rather. And then once that's all done, close it.
So basically, the list is basically a list of pointers to nodes.
Okay, yeah.
It's not a list of actual nodes, but a list of pointers to nodes.
Right. Okay, and then preserve a copy.
And then make a copy of it. So I'll have like a a list of all the data we started with.
Okay, and then we go into combine tree and then display, and then we delete it all when we're done.
Yeah.
Okay, so moving on to combine tree.
Right. So.
I'm still scrolling. Okay. So let's see here. That's where we take the tree list that we got from the file. Bool begin, bool small before next, and float frequency. So then there's the pointer variables, so we can make a binary tree out of it. Let's see here. Iterator.
I just declared a bunch of iterator variables there. So.
Okay. Okay, so while there are more than one items in the tree, small before next equals find smallest. Okay, so do we want to walk through find smallest real quick?
Yes. So then we go to that find smallest function.
Okay.
And it basically passes in 2 iterators by reference and then returns those values after it finishes. So.
Okay. Okay.
And it's basically finding the 2 smallest frequencies out of the nodes.
Right.
And that's how it makes the tree. Is if you read the instruction.
Yeah, because it combines the two smallest and then and makes children out of the 2.
Right.
Out of the
so basically, all this stuff is basically just finding the 2 smallest. Maybe it's harder to do with a list because they have to work with iterators and stuff. Mm-hmm. But that's basically all this is doing. Just looping through the list 2 times and finding iterators to the smallest and then the next smallest value.
Okay. Okay.
And then it will return a Boolean value telling which value comes before it in the list.
Right.
So we know the order, like if one's on the left and one's on the right. So.
Okay.
So basically, that function returns 3 data values there.
Okay. Okay. So let's see here. Where were we? Small before next. Okay, yeah. So small before next. Find smallest.
So it passed in the small it and next it, and those come out with the 2 smallest values. So.
Yeah. And then you make p left and p right small and next smallest.
If the frequencies are the same, then you order it by which one is on the left.
Yeah.
So. And then this next part is basically just creating the new node and then connecting the left and right nodes.
Yeah. Okay. Yeah.
And that new node won't have like a string of data. It'll just have a empty string with a frequency. So.
Yeah. So it'll just be just like the Huffman was in the book, right?
Right.
Okay.
Then you erase the nodes that you just combined onto that new tree.
Right.
And there's a lot of code here, but basically it's just trying to get it to insert it in the right place in the list. That's basically all I'm trying to do. It's pretty complicated, but that's basically what I'm trying to do there. So
yeah.
So you insert the that new node finally onto that where it says tree list insert it pnew.
Yeah, so you make a new node.
So that was that new node that you made way up there earlier.
Yeah,
So
with basically just the combined frequency of the two small nodes, right?
right, which and then connect it to the original nodes,
Yeah.
and then also the other thing, the last thing you need to do is take the last node and insert it into the right slot of the node that was erased.
Right.
And that's what I'm trying to do at the end there. So
yeah, so that it finishes out the tree, makes it 100, makes it 100.
mm-hmm.
Cool. Okay.
So yeah, it's a lot more complicated than that, but that's the gist of it. It's just finding the right place to insert the nodes, and then just combining the trees until it gets to just one root node.
Yeah. Okay. All right. And the last thing is display Huffman.
And notice that is not the sorted tree. It's the original list of nodes from your what you started out with. So it's
What's
that
that?
copy I made there, where it says preserve a copy of the leaf node list there.
Oh, right. Where is that?
It's right below the FN close there.
Right. Okay. There it is.
And that's what you started with, and it's just a list of all the data in alphabetical order, I think. So.
Okay. And so then you come here. Says here.
So just take that, just kind of loop through the leaf node list, and for each leaf, you just basically traverse the leaf from the leaf up to the root node.
Mm-hmm.
The root node doesn't have a parent node, so that's the way you can tell it's the root node.
Yeah.
So, and you just add on the 0 or the 1, depending on if it was a left or right node.
Oh, so. Right. Okay. I was wondering how that got done. Okay.
That was like the easiest way I could think of to calculate the Huffman code.
Yeah.
I was first experimenting with a recursive function, but that was just way too much work and brain power to have to figure out how to traverse the tree and find all the nodes. And
this looks like
this is the easier way. So
yeah. Okay.
And it's really neat because even though there are two separate lists, the pointers are all the same, stay the same for all the nodes. The pointers stay the same, so you can access from the sorted tree in that old list, even though the old list isn't sorted, all the nodes are the same. So pretty neat how you can just access them. And
yeah.
So, but that's the gist of it. Yeah. And then you're just erase, and you just have to put the root node in, and it'll just delete the entire tree for you.
Yeah. Tree list.begin.
And it sets all the pointers to null as well, so it does all the work for you there.
Yeah. Cool. I like it.
But yeah, I was really excited to get this working. I spent a lot of work on that, so really excited. But
what's Evan's last name?
Harrison, is it? Yeah. Evan Harrison, I believe.
Yes. Double check that. Yeah, no, it's good job with that, man. It's looks like a good bit of coding you did. Let's see here.
Yeah, really is a challenge to work with iterators and trying to find the, trying to find values with iterators. It is without indices.
Yeah.
Hmm.
Let's see here. Harrison. Second, do we know? Let's see, where's cool. Wow, that's because I was like, I was looking at it and like when they explained it in the book, it didn't sound like super complicated, but I could I like when working with iterators, I could see how it definitely would get like really really complicated.
And I was trying to figure out which data structure to use because they gave us a vector originally, and I didn't really see a way to insert values in between other values with a vector.
Yeah. Well, list makes sense anyway, since the node is already kind of a list. Okay, so really quick. So you saw I added our names there.
Okay.
So come over here to GitHub.
All right.
Oh, hang on. Actually, I need to save this first. Over here to GitHub. So it has the changes. It's sensing that I put a change in. Yeah. So that's what it used to say. That's what it says now. That's what it used to say. That's what it says now. And so now we just select all the changes, put in a summary, added names to author, commit to master, push. And come up here, refresh this real quick, add names to author, and now it's up there on the interwebs for all to see.
Wow, yeah. So is GitHub, is it just basically a file storage type thing, or just
basic is kind of, yeah. Let me show you something real quick, because like if I can, so since this isn't on your server, I can like mess with stuff like this. So like if I put in, well, like if I were to change this Huffman.cpp and did some, like, added some code to it that wasn't compatible with the rest of it, it would there's an algorithm in here that would catch that, and it wouldn't allow me to push it. Wouldn't allow me to add it without me first doing something to resolve the issue. So that makes it so that a bunch of different people can work on the same file without stepping on each other's toes. Because with the setup that we have now, I mean, it's not really a big deal since we're all working with different. We just make much different subdirectories, and it's not a big deal. But if we're all trying to work on the same piece of data, we would probably be deleting crap all over, deleting each other's stuff all the time.
Right.
But also another advantage to this is the fact that this isn't on the Linux server, and so like in CS246, you're basically working completely with Java and Android, and so it's not nothing is on the Linux environment. like, that, like, there aren't servers that you're going to be working with your group, and so this is something you have to do a lot.
All right, and yeah, I'm going to be doing that next semester, so I'll see how that goes. Huh.
It's a cool little tool. Then also, like, as I said, with this, like, with my new, I'm going to stop sharing here. With my new computer here, I have no idea how to access the Linux lab and do test bed from this computer. And as I said, like, I can't even log into our shared group on this. So, with this, I'm able to code from work, save it all up to the GitHub servers, and then continue coding when I get home. Yeah. All right. Anyway,
so you can't really submit stuff. Is that what it is, or?
No, I can't.
Okay.